So when solving a linear program, we assumed the values of all model coefficients are known with certainty. When it comes to all model coefficients, so all model coefficients include objective function coefficients, constraints coefficients. So, but the real world is not certain. So such certainty rarely exists. So sensitivity analysis actually help us to answer those questions about how sensitive the optimal solution is to changes in various coefficients in a model. And so in this statement, various coefficients include also constant, which are right-hand side of the constraint. So question is, how sensitive is a solution to changes in the coefficient of Cj and coefficient of Aij for constraints and Bj right-hand side constant. So to answer those, we can rerun the model, but we can also use sensitivity report to answer those questions. So we ran the built-in Excel solver to find the decision variables and object functions values using built-in Excel solver. So Excel solver will generate sensitivity reports. So we can use that sensitivity report to answer those questions regarding sensitivity. So what kind of questions we need to answer using sensitivity report? If you want to have some other questions out of this list, you need to regenerate the solutions and then you can answer. But some simple answers we can answer using sensitivity report. So that is the best way. So answer questions about amounts by which objective function coefficient can change without changing the optimal solution, as we had a discussion Monday. So we have a solution which is one of the corner points, right? So once we have optimal solution, production department will have a plan based on that solution because that solution is coming from the company level. The marketing department will change the prices of the product. Then because we maximize the profit, the product mix may be changing. That means the production planning department need to change the production planning. The second question is about the impact on the optimal objective function value of changes and constraint resources. So in the previous example, we had the 3 different constraints: pump, labor, and tubing. If we add extra pumps, because we had a good deal with the suppliers, so we could find several more pumps in a reasonable prices, then we want to see what is the impact of extra inventory. And then if you hire extra people, so you may have additional labor hours. So what's going to be impact of hiring new people on the firm's total profit? And when you hire people, some of them may not be skillful or they don't have experiences, but some other employee may have some experiences and they have skills producing X1 or product X2. And then they're going to save time to produce. So what is the impact changes in constraint coefficient we have on the optimal solutions? And so these kind of questions can be answered by using sensitivity report. So I try to maximize total profit G. The price of X1 is 350, price of X2 is 300. This object function is subject to 3 constraints. First one is the pump, second labor, third the tubing. So this is pump, labor, the tubing constraints, 3 constraints, and we have a limited resources of this. So last time I demonstrated how to draw the graph, and then if I doing again, see x1 and x2. Okay, first one, if x1 is 0, x2 will be 200 to draw the boundary line. So 200 here, and 200. So connect these 2 points using a straight line. That is the first constraint. Okay, thank you. There, give you a balance. Thank you. And this is the first constraint. Second constraint, if you have 0 for x1, x2 will be 1566 divided 6, right? So it's going to be these. I don't know exact numbers for that. Do you have? Let's do it. So if x2 equals 0, if x2 equals 0, 9x1 1566. So x1 will be 1566 divided 9, which is 166, 67, right? 60. Let's use a calculator. So 1566 divided by 9, 174. It means x1 will be 174. And if x1 equals 0, right, 6x2 would be 1566. So x2 will be 261. So let's see, 261 is here. I have 2 points. So draw the straight line. This is the second constraint. Constraint the boundary line. For the third one, tubing. Now, if x1 equals 0, 16x2 will be 2880. So x2 will be 2880 divided by 16 or 460.8. So x2 should be okay. We need to increase this. And if x2 equals 0 and 12x1 go to 880. So x1 equal 880 divided by 12, 240. Something wrong, right? 2880 divided by 16 should be
180.
It should be 180. Yeah. So, right?
Yeah.
Yep. Thank you. This should be 180. So x2 is 180. x1 is 240. And you draw this line. I'm bad. Let's see. So overlapped area will be this. This is our feasible region. As you know, our solution is one of these corner points. A, B, C, D, and this E. So A has origin 0.0. We need to draw the profit line. Okay, for this profit line, now we have z equals 350x1 plus 300x2. So you're familiar with this, y equal a0 plus b1x1. This is a linear line, right? x1 and y. Then a0 is the intercept. The b1 is slope, right? There's a delta x1 and delta y. So slope b1 equal to rise over run, which is delta y over delta x1. So you're familiar with this linear equation. So instead of having y, we're going to have x2. So x2 equal, no, 3. Z equal 350 x1 plus 300 x2. So if you move x2 to the left-hand side, 300 x2 equal z minus 350 x1. Now, so let's take off 300. So x2 equals z over 300 minus 350 over 300 x1. Now we know this is an intercept and this is slope. And you see slope is negative. Negative. If this is negative, it will have downward. If it is positive, it will have upward. This is positive, right? So do you have any questions so far?
No questions.
Okay. So because we have a slope, we can draw profit level curve. Means our slope is minus 350 over 300, right? This is equivalent to minus 175 over 150, right? Or this is equivalent to 35 over 30. And this is equivalent to minus 7 over 6, right? So now, see our profit line 350 over 300, right? So 350 is change of y and 300 change of x1. That means 350 is change of x2 and 300 is change of x1. So this is run, this is right. So 350 will be over here and then 300 somewhere here. But this is our scope to visualize. So we're going to take the second one. 175 over 150. So 175 over 150. So this is our profit line. I'm sorry. We are drawing the level curve. Also 35 over 30. 35 over 30. And also 7 over 6. So if you start from the origin point and then move up, right? Then as you see, profit lines, which are parallel lines, and then move up, you touch this point, right? But we know that is not for this point from the origin, so that's not our optimal solution. So move up, then touch this, but still can move up, and so now we know point D is our optimal solution. That's how we draw the profit line to touch the optimal solution. So the furthest point from the origin is our optimal solution. Now, question is, while we keep the same solution, can we increase over this price or decrease price? Or increase the price of this X2 or decrease of X2? So if we can increase or decrease of these product prices while keeping the same solution? What is the range of that? So we want to answer that. And additional question is, what if add extra pump? What if we add extra labor hours? So if we increase the profit line of this, again, G equals 350 x1 plus 300 x2. We knew that 300 x2 equals Z minus 350 x1, and x2 was Z over 300 minus 3 over 300 x2. Now, see, x1 price is 350. If we increase this number, so our slope will be faster or slower? It's going to be faster because if our profit line is like that, then faster means it's going to be steeper, right? So our optimal solution will be changing to this point if we increase at a certain point. Now, if we decrease, this is 300. Now, if you increase the price of X2, if you increase price of X2, the slope will be slower, right? Or if you decrease the price of X1, your slope will be slower. If you decrease price of X2, your slope will be faster. So to keep the same optimal solution, how much we can increase the price of X1 or X2, or decrease price of X1 or X2? So we want to answer that question. 122.78, which is G is from the 66,100. This is our solution. 122 aqua spa, 78 hydrologs, which are X1 and X2. So you see the reduced cost is 0 and object coefficient 350, object coefficient 350, and second object coefficient 300. So you're supposed to read the report. And then allowable increase 100. Allowable is 100 and allowable decrease 50. That means 350 plus 100, which is 450, and 350 minus 50 is 300. So if you change the price of X1 within this range between 300 and 450, you can make a better profit while keeping the same solution. So you're not going to change the solution, optimal solution, or you still can improve profit. Does it make sense to you? Any questions so far?
No questions, thank you.
Thanks. Now for the second coefficient of decision variable X2, original coefficient value is 300. Now, what is the allowable increase? What is the allowable increase of second objective function coefficient?
50.
Thank you. What is allowable increase of the second objective function coefficient?
So increase it is 50, the decrease is 66.66.
So increase 50, decrease is 66.67. Means you can increase up to 350, or you can decrease. So if you change the price of X2 within this range, you can increase profit or decrease profit while keeping the same solution. So if you have $300, so marginal value will be zero. Marginal value is zero. So then you see the reduced cost is zero, right? Those are the marginal value. So reduced cost of X1 is zero. It means if you increase the price, your profit will be increased. And if you increase the price of 350, then your total profit will be increased while keeping the same optimal solution. Optimal solution means with these two values, X1 and X2. That's how we interpret the first table of variable cost. And let's take a look at the second group of constraints. Oh, yeah, any questions so far? Now, constraints. See, we have cells D9, D10, D11, which represent pumps, labor, tubing required, used, respectively. The final value is 200, 200 and 1500, 1566. So, that is 2712. These are the left-hand side value, and these are the right-hand side value. So what are the discrepancies, differences between left-hand side and right-hand side? Zero, for pumps, zero, labor hours, and 168 tubing. So you have a zero here. So you don't have an extra pump to produce product 1 and 2 after you produce 122x1 and 78x2. Then you have a zero labor hours left. So that means you cannot add extra labor hours to produce x1 and x2. If you produce 122x1, 78x2. Right. So that's why you have final value of this left-hand side, right? And the constraints of RH side, right-hand side are these numbers. Those are the constant. And the schedule price is a 200 for pump, 16.667 for X2, 0 for X3. Now, because you consume all pumps and labor hours, those are binding. Binding variable, binding constraint, and non-binding. So for the binding constraint, you have zero resources left. For non-binding constraint, you have extra resources. So you have 168 feet of tubing left for produce X1 and X2 in the future. So non-binding. So if this is non-binding, you see schedule prices 0. Because this is non-binding, even you change this third one, third, first, second, third. This third, even you add extra tubing, it is not going to generate extra benefit. So that has a shadow price of 0. Now, you don't have any pump on the warehouse shelf, but what if you add extra pump? Because you had a great chance to talk with the supplier and they're going to supply one extra pump. Then if they have 2 or 1 pump, actually is going to helpful to generate better profit? Yes. So you should the shadow price of a pump. What is the shadow price of a pump? Your profit Z will be 66,100 plus if you add 1 extra pump. The shadow price is 200. So your total profit will be 66,300. That is, you see the increase of total profit from previous solution. Did you get it? Can I move forward?
Yes, Professor.
Yeah, Professor, you can move forward.
So now we're talking about inventory pump. But if you add 100, 200 pumps that still generate profit, we have no idea. So take a look at the allowable increase, allowable decrease. So original pump was 200, right? And then allowable increase 7, allowable decrease is 26. So that means if you add up to 7 pumps, there will increase profit. But if you add 8 extra pumps, 7 will generate profit, but 1 pump will be left over. So it is not going to generate profit. Actually, it will be inventory cost. So you can add up to 2 or 7 pumps to generate profit. But if you decrease number of pumps because of defective pump, now 1 pump you find out is defective. So you only have 199, then your profit will be decreased by $200. It is going to be $65,800. It does make sense, right? That's why we don't have extra pump, but we can add extra pumps with a good relationship with the suppliers to generate profit, but you cannot add more than 7 because after 7 pumps, it will be your inventory cost. So you need to have a good quality of pumps and maintain it well to make sure you can supply 200 pumps to produce X1 and X2. So if you fail to maintain good quality of pumps, actually your company's profit will decrease. So let's talking about labor. Now, labor constraint is a binding constraint. Now, if you hire a person 8 hours, is that going to generate better profit? So we need to take a look at the shadow price. It is positive, yes. If you add 1 extra hour, it's going to generate more profit by 16.667. So because we're adding 8 hours, shadow prices of second constraint is 8 times 16.667. So that will generate extra 133.3 $6. Yeah, so you can hire people, but how many employees can you hire to generate profit? Because after a certain number, it's going to be extra labor hours, because that will violate one of other constraints. You cannot meet the model's constraint. So we need to take a look at allowable increase and allowable decrease. So 156 allowable increase, the 234 allowable decrease, 126, right? So 156 plus 234, so 17800, and 1566 minus 126, 11440. Within this range, your profit will go up and down by $16.66, $6.667. But if you add more than 800 labor hours, there'll be extra labor hours, which is not necessary. So now let's see, 234 hours. If you assume one employee work 8 hours, then how many people you can hire? 234 divided by 8, 7.2. $29.2, so almost 30. So if you hire 29.25 employee, you still can generate profit. So if you can hire as much as you can, you need to do it. So HR department will work on it, but they can be permanently or temporarily hired. Again, and the same concept. If one of your employees has sick leave, they're not coming to the workplace, then you're losing profit. Does it make sense? Now, one thing we need to take a look at is, now we only produce two product type. Now we have X1, X2. Now, if we introduce new product X3, which is the book says the name of product is Typhoon Lagoon. So each company has a production development company. So they're very excited to introduce new product in the market. X3 Typhoon Lagoon. So X1 and X2 were in the market. Now we want to have a new product, X3. So you want to see X3, the marketing department think that should be $320 in the market. They already did the research. But we need to think of that product will help the company generate profit or not. So our shadow price is of the product 200. Shadow price of these 3 products. So 200 and 6.6. So, right? Now, to produce Typhoon Lagoon, we need information of resources. So if you want to introduce Typhoon Lagoon, that's going to be max z equal x 350 x1 plus 300 x2 plus 320 x3, or this is a new product, subject to 1x1 plus 1x2. Typhoon Lagoon also need 1 pump, and we only have 200. And then labor hours 9x1 plus 6x2. To produce x3, you need 8 labor hours, but we only have 1566 labor hours. Thus constraint tubing 12x1 plus 16x2 to produce Typhoon Lagoon, Typhoon Lagoon, we need 13 feet of tubing. We only have 288 tube. Now we introduce new product, so we need these resources to produce Typhoon Lagoon. 1 pump, 8 labor hours, 13 feet of tubing. So if we produce 1 Typhoon Lagoon, that's a 320. 320, right? 320. Then to produce Typhoon Lagoon, our extra cost will be, no, not extra cost. So our schedule price, that can be cost, will be 1 times. If you add 1 extra pump, schedule price 200. Right. Then, if you add extra 8 labor hours, then schedule price 6.667. And then, if you add 13 feet of tubing, then schedule price 0. So 320 minus 200. Let's calculate. 8 times 16.667, 133. This is, oops, 133.33. So the total schedule price, total cost will be 333.33. So now you see this result in minus. Do you see that? This is minus 13.33. Did you get this? Now, if you produce 1 extra Typhoon Lagoon, your profit 320, but you need to add resources by 3.33.33. So that is actually losing money. It doesn't generate actual profit. So it's not good to introduce new Typhoon Lagoon. However, Typhoon Lagoon need 8 extra labor hours. Looks like you cannot change this because 1 is the minimum number of pump to produce that product. Well, you see, while to produce X1 is 9 hours, X2, we need 6 labor hours. You still need 8 labor hours for type 3. But if you hire skilled person who got experiences from different industry, maybe, then if you need 7 labor hours, what's going to be the result? Now, instead of 8, if you need 7, actually that will generate profit. So you need to think of innovative way of making product instead of using 13 feet of tubing, and maybe just need 12 or 13, but that doesn't help. Anyway, if you decrease number of hours to produce 1 unit of third product, X1, actually that generates profit. Any questions so far? Now, so if you are HR manager and you may have question like this. All right. Okay, if you want to hire a skilled person, instead of paying $16.667 per hour, because $16.667 per hour, that's even point. So if you want to hire a skilled person, how much you need to pay for that? 3 training of the Typhoon Lagoon, right? Then our schedule price is should be less than 320 to make it profit. So now, see $200 for 1 pump, right? Minus. Okay, I'm gonna rewrite this. For 200 for 1 pump plus 16.67 schedule prices times L, the same, plus 13 times 0. So that is 120 minus 16.67 L, right? That should be greater than or equal to 0. If it is 0, it's even point. If it is greater than 0, that actually have extra profit. So I'm going to delete this graph. Now, 16.67 L should be less than or equal to 120. Should be less than or equal to
almost 7.2.
7.2.
Yes.
Thank you. You need to hire someone who can produce the product less than 7.2 hours. Right? So 2.2 hour, then maybe you can pay up to 16.667, or you should pay less than $16 per hour. So this is the labor hours to produce X3.